Why do prosthetics cost an arm and a leg? And what can we do about it? Prosthetic devices are known to be costly, but it's important for high-quality components to be used so that the device may function properly. We reached out to a few experts to find out if there's a way to create quality devices while keeping the cost low. MDT. How are recent developments in materials, components, and fabrication technologies helping designers improve the functionality and performance of prosthetic devices? Are any of these developments helping to make prosthetics more affordable? The approach of designing a product is not focused on its creative and aesthetic elements, but on its functional purpose to respond to users' needs and meet standards, rules, and regulations. To meet them, projects in the area of prosthetics should have a social concern in order to improve quality of life of the amputee. It needs to integrate osteology, arthrology, mythology, engineering, ergonomics, sustainability and appropriate materials, and sustainable technologies or other areas from the earliest stages of design. This approach led to changes in the methodologies applied by the different people involved in the development of projects, which designers cannot ignore for improving prosthetic devices. Despite progress, prosthetic prices are still thousands of euros, making them unaffordable. Yet, multidisciplinary teams in manufacturing technologies makes it possible to produce the low-cost prostheses with adequate quality. The development of the new materials, 3D scanning, the dropping of patents, and availability of free software and STL files on the web allow the global community to easily generate the STL files needed to print the components to build these prostheses anywhere in the globe. Creating prosthetics has become more accessible with 3D printing. With current technology, prosthetics can be modeled, designed, and controlled based specifically on the user's needs. Examples include voice activation, button controls, and sensors to attach to the user's muscles. Today's technology has allowed prosthetic hands to handle most anything, like eating meals and tying shoelaces. Scientists are also experimenting with pressure sensors in the fingers and artificial hands to sensory nerves, giving the user the actual feeling of touch. When I was designing one, I researched how tendons work in fingers and how I could replicate it to make movements more realistic. The wove fishing wire up and down the front and back of each finger. They act as tendons and use more motors to pull the wire. Then I programmed the motors to pull the tendons for different gestures. Originally, prosthetic limbs had seemed like something out of a science fiction movie and only accessible to unique individuals. Unfortunately, a commercially made prosthetic typically costs between $5,000 to $50,000 depending on its functionalities, which means a number of people around the world who need them are unable to afford them. However, 3D However, 3D printing has made a creation of prosthetics affordable, faster, and scalable. A model can be made and used for mass production without costing a fortune. Prosthetics arms are smart, motors allow for smooth movements, and finger sensors provide information for better controls. Nevertheless, users can only take full profit of these prosthetics if they can be controlled easily and is still room for improvement. Direct neural control is an vision goal. Just by thinking, the prosthetic arm should react accordingly, while electric feedback from finger sensors should be sent directly to the user's brain. To enable this, the direct interface is needed between the prosthetic device and the user's nerve system. For example, IMPEC develops this by fabricating a tiny implantable chip in the electrodes of both the recording of neuron signals coming from the brain and the transmission of sensory feedback towards the brain. The chip is implemented in the peripheral nerves, so minimalization, long-term biocompatibility, and hermeticity are crucial. As such, the neural damage upon implication is minimized. Using biocompatible medical-grade materials and noble metals is not making this chip embedding cheap, but the control of its prosthetic will give the amputee a better quality of life. Research and development is crucial for the improvement of existing prosthetics. The implantable chip being developed aims to interface between the patient's nerves and the prosthetics, allowing bidirectional communication between the prosthetics and the nerve cells. The chip allows for the for thought-driven control of the prosthetics, which is more intuitive and hence easier for the patient. The developments presented don't aim to make prosthetics more affordable, but want to contribute to more sophisticated prosthetics that will feel and behave more like a normal arm and hand, as such significantly improve the patient's life.